In this video, I'll explain how to find the total derivative of a given function. Suppose you have a function u equal to u of x comma y. That means u is a function of two variables. X and y are the two independent variables. And x is a function of t. Also, y is a function of t. So, in this case, the total derivative of u is denoted as du by dt. Total derivative of u is nothing but the derivative of u with respect to t, that is obtained using dou u by dou x into dx by dt plus dou u by dou y into dy by dt. This is because u is a function of two independent variables. Whenever you have a function of two independent variables, then you need the partial derivative of that function. That's why dou u by dou x. With respect to the variable x, it is partial derivative. Now x is a function of single variable, that is t. Hence you have here dx by dt. Plus similarly with respect to the second variable y, the partial derivative of u with respect to y into y is a function of single variable t. That's why the derivative dy by dt. This is called as the total derivative of the given function u, because u is, in turn, it is a function of t, because x is a function of t and y is a function of t. Hence, you will get the total derivative of the given function. The process of finding total derivative of given function is called as total differentiation. If you have a function of three variables, then the same method is applied, where x equal to x of t, y equal to y of t, and z equal to z of t. These three independent variables are functions of t again. So in that case, total derivative of the function u is represented as du by dt, which is equal to dou u by dou x into dx by dt plus dou u by dou y into dy by dt plus dou u by dou z into dz by dt. So this is how we get the total derivative of given function which has three independent variables. Let us see one example. Say the first problem, if u equal to this function and x equal to t square, y equal to 3t, find the total derivative of u. That is du by dt equal to, we have dou u by dou x into dx by dt plus dou u by dou y into dy by dt. So let us find out one by one. Dou u by dou x, partial derivative of u with respect to x. You have to treat y as a constant. Derivative of x square is 2x plus y is a constant. Derivative of x is 1 plus derivative of y square is 0 into dx by dt. To derivative of x with respect to t. So that is derivative of t square is 2t plus dou u by dou y is derivative of u with respect to y partially. So derivative of x square with respect to y is 0 plus with respect to y, x is a constant. So derivative of y is 1 plus derivative of y square is 2y into dy by dt. Derivative of y with respect to t, that is 3, which is equal to 2 2s 4 into xt plus here 2yt plus 3x plus 6y. You have to write every term in terms of t. So 4 into x means t square into t cube plus 2 into y means 3t, 3t into t, that is 6t square plus 3 into t square plus 6 into y means 3t, 18t. So this is the total derivative of u with respect to t. Final answer should be in terms of t, that is by back substituting x as t square and y equal to 3t. Now see the second problem. If u equal to e power x into sine of yz and x is t square, y is t minus 1, z equal to 1 by t, then you have to find out du by dt at t equal to 1. They have specified a point here. So first write du by dt equal to ux into dx by dt. I'll write ux instead of dou u by dou x plus uy into dy by dt plus u into z uz into dz by dt. So partial derivative of u with respect to x, keep yz constant. Here in the second case, keep xz constant. In the third case, keep xy constant. So ux is sin yz constant. So e power x derivative is e power x into dx by dt. Derivative of t square is 2t. It is with respect to t. Plus uy here in this case, x and z constant. So e to the power x is constant. Then sin of yz, z is constant, but there is y along with this z. So first to find the derivative of sine of yz, which is cos of yz, into z is a constant, derivative of y is 1. That is because using the chain rule. So altogether plus uz is again same, e power x is constant, derivative of sine yz is cos yz into, now y is a constant, derivative of z with respect to z is 1. So here in this case, then we want dy by dt also. So dy by dt is the derivative of t minus 1 with respect to t, which is 1. Minus derivative of 1 is 0. That's why just 1. So plus here we got this dz by dt into d. Here we got this. Now we want dz by dt, derivative of 1 by t, which is minus 1 by t square. Now, in the question, they have asked du by dt at t equal to 1. So, I need every term in terms of t. Therefore, du by dt is equal to sine of y is t minus 1, z is 1 by t. That you have to substitute here. Sine of t minus 1 into z is 1 by t. That is like this. Into e to the power x is t square into 2t. Here already you have plus, replace x y z by these values so that every term is in terms of t. So e to the power x is t square into cos of t minus 1 by t into z is 1 by t, plus again e to the power t square into cos of yz. So cos of t minus 1 by t into y is t minus 1 into minus 1 by t square. Now we want the derivative at t equal to 1. So substitute t equal to 1 here. What you will get is, I'll write here, du by dt at t equal to 1, which is equal to, so here anyway it is 0, e to the power 0, e to the power 1 square, which is 1 into 2 into 1, so 2e. Here cos of 0, t equal to 1, 1 minus 1, 0 by any value, it is 0. So cos of 0 is 1 now. T equal to 1. So substitute here. T equal to 1 means 1 minus 1, 0. Sine of 0 is 0. 0 into any value, it is 0 here. Plus, so in this case 1 minus 1, 0. But cos of 0 is 1. So 1 into e power 1 square. So e power 1 square is e. So 1 by 1 is 1. So e into 1 it is. Plus third term here again, cos of 1 minus 1, 0. Cos 0 is 1. 1 minus 1 is 0 here. Therefore, the whole term becomes 0. Hence, the value of du by dt at t equal to 1 is e. I hope you understood the concept of finding total derivative. Thank you for watching.